The first major feature we'll get to on the OpenShift side is build automation. OpenShift provides easy workflows for building and deploying containerized applications. Web developers can select a item out of the service catalog, so provide their repo information and application name, click create, and they're off and running with a new application in the cloud. OpenShift will report back build statuses, stream the logs of the build, and return a application URL immediately that can be asked, that can be used to access your application. Once the application is fully deployed and up and running, you can use these arrow keys to scale up or down with a click of your mouse. OpenShift also uses a tool called source to image to combine source repos and operationally maintained builder images to produce the resulting application container images. Source to image is available as a standalone project for use with Jenkins or other externalized build systems. OpenShift provides git push to deploy style automation in the application configuration section. This particular application shows a configuration page with a generic webhook URL and a GitHub webhook URL. These webhook URLs can be pasted into your GitHub Enterprise, GitHub, GitLab, Bitbucket. Most modern revision control systems will have support for a webhook integration that allows your revision control system to call OpenShift and notify it when new code has arrived. This allows a full continuous delivery automation anytime commits land in your associated repo. This is great for iterating on solutions post-commit, but as a developer, I actually want to get feedback before I make my commits. Here's some examples of how OpenShift helps fulfill that use case as well. OpenShift provides centralized logging and metrics via Elastic, ElkStack, and Prometheus. You also have easy access to terminals using kubectl-exec or ocexec. Once connected, you can use kubedns to contact Kubernetes services by name. This example shows using curl to contact a Kubernetes service by service ID http-base. Environment variables are easy to add to deployment configs or other files using the ocenv shortcut. Here's the live development example I mentioned earlier. If I have a local clone of a repo and a remotely running pod defined by oc-get pods in this example, I can use the oc-rsync command in order to synchronize changes from my local repo into a remotely hosted container on the platform. This workflow allows me to preview changes before I commit by syncing content into the running container. Once I'm happy with my changes, I can then use git commit and git push in order to see the automation pipeline rebuild and redeploy in order to confirm whether my suspicions are correct, whether my testing looks good. OpenShift also helps you share and replicate your success. The service catalog and brokers are one solution that helps make this very easy. You can go to www.openservicebroker.api.org for more info on this topic. The left side of the screen shows a service catalog integrated into OpenShift with a variety of icons that can be used as starting points for developers. The right side of this diagram shows pluggable broker backend design by a variety of broker providers. One solution is the OpenShift template broker. This has been included in OpenShift throughout the most of the OpenShift 3 series. New features in OpenShift are the OpenShift automation broker or Ansible playbook broker. This allows generic system automation to be fired off with a click in the service catalog. An Amazon Web Service Broker is available for launching AWS services via a OpenShift Service Catalog front end. There's a collection of other service brokers available from additional service providers and platform providers as well. A lot of other folks like Cloud Foundry and IBM are also working on this mechanism for sharing and leasing services internal to enterprise organizations. You can use the template broker as an installer to onboard new web developers. For example, if I were to run OC create-f on a local template file, I can install the template into my current project scope, making it easy to reuse. I can also use OC create-f on a remote file in order to install it into my local project context. Here I've provided a multi-service application example bundled up as a template file. If you run OC create-f on this file, it should install it into your service catalog. You should then be able to click on the solution and deploy the bundle in order to basically deploy about 7 different web services altogether, or 7 different API resources. When you're done, you should be able to run OC get all to list all the resources that were created using this single web workflow. Hopefully this shows how it can be very easy for advanced developers or lead developers to work on these lower level Kubernetes abstractions and standardize the collection of what the more average web developers should be working on. Team leads would package these things up, make them as a template, install them in the catalog, and then average web developers could come through, select, I would like stack A, please, that has already bundled up everything they need in order to be productive without a assumption that they would need to learn what is a pod, what is a replication controller, what is a deployment, what is a registry, what is a route. Really all the average developer needs to know is what language they're working on, which stack to click on, and where their repo is located. And we should use standard Kubernetes resources in order to fulfill the request and provision a URL that they can use in order to contact their application. For more information on Kubernetes, you can check the official Kubernetes/Kubernetes repo on GitHub. This is where all the Kubernetes sources and official releases are maintained. Kubernetes docs are available at kubernetes.io/docs. You can also find official sources and releases for OpenShift at github.com/OpenShift/origin. OpenShift docs are available at https://docs.openshift.com. If you'd like more learning opportunities, feel free to download a free O'Reilly ebook, Deploying to OpenShift, at www.openshift.com/deploying-to-OpenShift. You can also go to learn.openshift.com for free access to Kubernetes and OpenShift learning materials available right in your browser. For more ways to try OpenShift Origin or Minishift. Developers can try Red Hat Code-Ready workspaces for fully containerized development, including an IDE. OpenShift Online is an easy way to try OpenShift in a hosted manner using the starter or pro plans. OpenShift Dedicated is a way to have OpenShift operated by Red Hat and available on AWS, GCE, or Azure. OpenShift Container Platform is the most analogous to RHEL. It's supported by Red Hat, but administered by you. And we would expect RHEL and or CoreOS as the host OS on those machines in order to protect the host from being compromised and provide the multi-tenant security that OpenShift provides.